Hi there, Turgeon here, bringing you physics from afar. I don't want to go over every single step of the quiz, but I feel like you can learn a lot from hearing the rationale behind the answers. The scores were low, we all expect them to be, but what we're really concerned about is the opportunity for improvement here. So this one is pretty obvious. If it's constant velocity, if it's terminal velocity, that's got to be constant velocity. So these two forces are equal but opposite. That's a force of air friction. They later do refer to it as F sub air, so it's probably better to integrate that reference back there. Okay, so force air, force weight. The units, look at this one. So what I did was simply look at the equation. I mean, I had the same reaction as you, I'm sure, at first, and I was like, I don't know the units of this thing. So all I did was write down the units for what I did know. So the units of a Newton, so I put newtons equals, C is unknown, then we have meters times meters squared. That's not mass, that's meters times meters squared, and then that's divided by seconds squared because the v squared is a meter per second and that's all squared. So then I wrote out the base units of a Newton, kilogram meter per second squared. Algebra solve, you end up with kilograms equals c times m squared times meters squared. So this unknown constant c is kilograms per meter squared. Now, this was a critical part. The whole idea is to understand that they're telling you, they're starting to set up this relationship between radius and velocity. Okay, so it says I'm only supposed to use quantities that I can measure in the lab. So I know that the air force is equal to mg. Think about that. Pause the video if you need to. I know that v is a square root of, I just solved this equation above and I wrote something in terms of v. See, I just solved this for v. Then I went further and said that is actually the terminal velocity or terminal speed. Then I went further and I said I know that air is equal to mg and it's equal to m times b times g, which is something I can measure in the laboratory. I know you think maybe you can measure air force in the laboratory, but really what you'd be doing is measuring m times b times g. That is mass. Okay, so here's my key equation. Now they say, they're saying relating the radius to the terminal speed. So the key is relating those two. So I want one of them on, I need that the radius and the terminal speed be on different axes. That's the key. And I don't like the square root stuff, so I just decided to square the terminal velocity so that I end up with 1 over CR. I arbitrarily decided to do this to pull out that constant. You could have done 1 over r, it's fine. What matters is I'm going to get a straight line. I checked my units of my slope over here. This is kind of interesting. And it worked. I don't want to waste too much time explaining that. Let's get on to the experiment. So in the experiment, we don't need to measure all this other stuff. We don't need to measure the mass. They're saying the experiment is to change the radius, so that's all we got to do. This is the key. So sorry about the quality of the scan. I hate these scroll bars are so annoying. It won't let me scroll. All right, so my box. Okay, so first thing you got to do is you absolutely have to measure the radius. The other thing that you need to do is I added this after the fact, and when I realized, no, you need to make it clear that you're doing different radii. You need to make it clear that you're going to do something with your motion sensor or with your stopwatch and meter stick so that you are ensuring somehow that you're getting constant velocity because the thing's not going to reach terminal right away. You need to specify how you're going to get the velocity from that graph, and then you need to make sure, this is one part that I forgot to do, you need to say whatever I get, I'm going to repeat it multiple times for the same radius. And that's it. Just really pay attention to those parts.